This is Jambo Radio. Hello, and welcome to the Science Show on Jambo Radio Scotland, broadcasting from the city of Glasgow. Of course, we're definitely in a party mood today because the Nobel Prizes have been announced, at least some of them, and we'll be talking a little bit about that today. As you already know, on this show we explore the developments in science and technology, especially how these developments affect our everyday life. So on today's show, we're going to be talking about an interesting topic, and the topic is that of algorithms. And we have an expert with us in the studio who's going to shed some light on algorithms and how they work and so on. And as you know how we do. This is a STEM show. STEM stands for Science, Technology, Engineering, and Mathematics. And today our topic is going to be more in the area of mathematics and specifically computer science. So we're going to enjoy that today. So as I said earlier, the topic is the truth about algorithms, and the question for the week is, have algorithms taken over? Yes, perhaps that's something that's been on your mind before, maybe something you've seen online before. So we're going to be exploring that topic and that question today. Well, I'm your host, Dr. Adetunmise Dada. I'm a lecturer in optics at the University of Glasgow. And of course, this is the Science Show on Jambo Radio Scotland, broadcasting from the city of Glasgow. And we're live. And don't forget, you can listen to us on DAB. That's whether you're in your car, whether you're at home. If you have a digital radio, you can catch us. And you can also listen and watch us live on jamboradio.co.uk. So that's going to be online as well. And if you happen to have missed some episodes in the past, you can watch these episodes and catch up with them through our Jambo Radio Scotland YouTube channel. So let's do a quick run through to see and just have a taste of what we're going to be enjoying today. To start with, as usual, we're going to be having our science news highlights, where we'll be looking at different headlines from all over the world. And after that, we're going to have an interview, the introductory part of our interview with our guest that we have in the studio with us today. And then we'll delve into the topic a little bit, the topic of algorithms. So the truth about algorithms is the title of our discussion. And then after that, we're going to get to know our guests a little bit more. We're going to talk to them about their research and their activities and other aspects of their personality as well. So again, as we said today, there's going to be a little bit of a spotlight on the Nobel Prizes and the announcements that we've had in the last couple of days. As usual, we'll conclude the show with jokes and with a fun song, STEM song. And we have a little surprise for you at the end as well. So we'll be looking forward to that. So you're advised and encouraged to stick around and stay tuned. Stay with us until the end of the show. So before we get into our science news highlights, let's briefly introduce our guest on the show today. Our guest is special indeed. Today we have a mathematician, I'd like to say, and also a computer scientist in the studio. She's by the name of Dr. Sofiat Olaosebikan. And hello, Sofiat. Let's say hi briefly to you. How are you doing today?
Hello everyone listening. I'm Dr. Sofiat Olaosebikan, a lecturer in the School of Computing Science, as the host has introduced. And I'm doing fantastic, just trying to get my head from the work zone into the radio station zone. Yes,
that's usually necessary, isn't it? So you said you pronounced it as Sophia, I noticed.
Well, there are too many versions of that name, so even I don't know how to pronounce my name properly at this point. Yeah,
I know both versions. I know Sophia and I know Sofiat. I'm a Yoruba as well, and you're Yoruba too.
Yes, I am. But if we want to go for the correct pronunciation, because my name is affiliated to the Islamic version, it would be Sophia.
Sophia. Yeah, I see. Interesting.
So.
Sophia. In Yoruba, we say Sophia.
Yes, the culture and the traditions affect the pronunciation. So
indeed. It's just that's the same thing. I remember, so my name is, my middle name is Charles. And, in English we say Charles. When I got to Sweden, they call me Karle,
Oh.
So the same name can sound completely different in another language. So that's understandable. It's really nice, yeah. So we'll be getting to know Dr. Sofiat Olaosebikan even much more later in the show. And again, just as a reminder, the question of the week, have algorithms taken over? So that's something we'd like you to keep in mind as we develop our topic today. So let's get into our science news highlights now. Science news highlights. So we have only 2 headlines today, and for good reason, because the first headline is about actually a development of a story that we covered in previous episodes. Asteroid struck by NASA leaves 10,000 kilometer trail. So we'll see what that's about in a moment. And the second headline we'll be looking at is Nobel Prize announcements. Explorers of the spooky science of quantum entanglement win the 2022 Nobel Prize in Physics. Yay! Now that's a very interesting announcement, because you will understand why later. Let's get into the first one. So asteroid struck by NASA leaves 10,000 kilometer trail. Now, the image is being put up for those who are watching live, but the image being captured by a telescope in Chile actually shows the effect of the impact that we reported in the last episode. So this telescope captured the remarkable picture of something that looks like a comet, but it's really just a plume from the moon orbiting this asteroid that was being targeted by the mission. Now, the probe was crashed last week to test whether asteroids that might threaten the Earth can be nudged safely out of the way. Now, scientists are working to establish whether the test was a success and whether the asteroid's trajectory has been altered. Now, this whole project cost about $325 million. That's about 240 million pounds, and it's called the DART mission. Now, this mission saw the probe deliberately smashed into the asteroid, destroying the spacecraft in the process. And the hope is that then the asteroid, which is actually a moon that's surrounding a much bigger rock, will change course significantly. Now, one of the actual director of the planetary science at NASA, she said, "We're embarking on a new era of humankind, an era in which we potentially have the capability to protect ourselves from something like a dangerous, hazardous asteroid impact." What an amazing thing. We've never had that capability before. And that's actually quite an interesting thing. So they will determine whether the mission has been a success by studying the changes to the orbit of Dimorphos, which is the moon that was impacted, which is just just a smaller rock that's orbiting a much bigger monster, Didymos, which is the main asteroid in the binary system. Now, the name of the name of the mission is DART, and that's just an acronym for Double Asteroid Redirection Test. So scientists always find a way to get very interesting acronyms for their projects. So, of course, DART is also a relevant sort of acronym as well. So this mission, of course, was designed to do exactly what it says, to be a dart that hits a target perfectly and precisely. Now, this technique that they've used in this mission could be used if an asteroid was, threatening the Earth at some point in the future. And of course, the idea is simple. What makes it particularly significant, again, is the distance away and the size of the object that was targeted. It's so small and the distance is so far away that it's really, really impressive as a technological feat. So that's quite an interesting one, development on that story. Okay. So now to the second headline that we're going to be covering in today's news highlights, and it's to do with the Nobel Prize announcements. Okay, so Nobel Prize announcement. explorers of quantum entanglement win 2022 Nobel Prize in Physics. This is something so exciting for a lot of researchers, a lot of physicists, and in fact, I think should be exciting for everyone, because actually the study that was conducted by these three men, Alain Aspect, John F. Closer, and Anton Zeilinger, is to do with quantum entanglement. It has profound implications, not only when it comes to the understanding of mankind as to how the universe works, but also it has very huge technological implications. So the official statement said that the Nobel Prize was awarded in equal parts to Alain Aspect of the University of Paris-Saclay, John F. Closer of John F. Closer and Associates, and Anton Zeilinger of the University of Vienna for their pathfinding work in quantum mechanics and quantum information science. And of course, these three scientists, I happen to know, at least I know two of them personally. John F. Closer, I've not had the pleasure to meet. So they worked independently. Yeah, that's a picture of me and Zeilinger about 12 years ago. I can't believe that was a long time ago. Anton Zeilinger was 65, now he's 77. And I remember that conference, that was a conference we had in Stockholm about quantum information. And I remember Zeilinger giving a talk, and the chairman of the session, I remember him pausing to say, okay, now we're going to have the announcement of the Nobel Prize. And that was 2010 when graphene won the Nobel Prize. And I remember him saying, oh, maybe one day one of us in this audience is going to be a winner of the Nobel Prize. And it's just interesting to see that actually that happened this week. So many congratulations to Professor Anton Zeilinger. So just a little bit more on the actual, the work that won the Nobel Prize. So this phenomenon called entanglement is something that has become an essential aspect of modern quantum technologies. It's so counterintuitive that, even Einstein, it seems so impossible that even Einstein was a bit at odds with it. He couldn't reconcile the idea that measuring something in one location can have an effect on the measurement result of something else in another location. And the effect seems to be, instantaneous. And, Einstein, with all his work on general relativity and causality, space-time, he found that to be something questionable. So that led to a lot of discussion, which we won't go into on today's show. But it's just interesting to see that, experiments that verify that actually that's how the universe works has led to so much development in the field of STEM, in communications, in quantum computing, so many applications for the future as well. So that's a really exciting news. So anyway, there are other Nobel Prizes being announced, of course. I'll just touch on briefly the chemistry Nobel Prize this year. The Nobel Prize in Chemistry 2022 was awarded to Caroline R. Bertozzi, Morten Meldal, and K. Barry Sharpless for the developments of click chemistry and bioorthogonal chemistry. Now, this is an interesting whole new topic. Basically, the idea is in click chemistry, molecular building blocks snap together quickly and efficiently. Thereby the click aspect of it. So that's something that maybe we'll explore in another episode of the show. But for now, we'll get back to today's topic, which is all about algorithms. So the truth about algorithms and the question, have algorithms taken over the world? All right. So now, before we do that, let's get to know our expert in the studio a little bit. And that's Dr. Sofiat Olaosebikan. And once again, it's really, really nice to have you in the studio with us. It's a real pleasure. So it's nice to have someone who actually knows about the topic, about algorithms, about computer science. And we'll have, a few questions about that for you later on. But to start with, we'd just like to get to know you a little bit. We'd like to know about your background. We'd like to know where you were born, where you went to school, how you wound up somehow in Glasgow, in Scotland, doing world-leading research.
Yeah, that's a very long story, and I don't think we have enough time to cover all of them.
We can try. We can try.
We can. And feel free to interrupt me at any point in time.
No problem.
So I was born in Lagos, Nigeria. So Lagos is one of the, in fact, most popular states in Nigeria. And then for the first 24 years of my life, I was in Lagos. I went to the University of Ibadan to study mathematics. Nice. And maybe a little bit, back the story up a little bit. When I finished my secondary school at the age of 15, my dad bought me a desktop computer, and just being around that, playing with solitaire and playing with paint and just doing stuff that I can't explain, that got me interested in computing in general. But I tried to get into computer science like twice, the University of Lagos. There are more people than spaces in the universities. I couldn't get in. Eventually, I found myself doing mathematics at the University of Ibadan in 2008. Nice. And so I finished the secondary school in 2005 and got into the university in 2008. So while doing the math, I always loved mathematics, even before I found the passion for computer science. I was very good at problem solving in secondary school. The only subject I had A in was mathematics. Wow. And so I was always, I found problem solving. I'm in my element when I'm solving problems. So doing math at the University of Ibadan, I always wanted to do computer science, and I go to the Department of Computer Science to try and borrow some of their courses, and computing wasn't taught in an exciting way. There are no computer labs, we write codes on paper, so I never took any course from there. But the interest was sustained throughout my university days, and it wasn't until I got a scholarship to go to Ghana in 2015. Nice. And everything changed for me. So I went to the African Institute for Mathematical Sciences in Ghana, and this is an institute founded by Professor Neil Turok, who is a physicist at some institute in Canada, and he believes that the next Einstein would be from Africa. So what he did was set up an institution where he brings in lecturers from outside Africa to train mathematical science students in Africa. And they have center in South Africa, in Cameroon, Tanzania, Senegal, Ghana, and Rwanda. So they take up to between 50 and 100 students every year, and they train them on a 10-month master's program in mathematical sciences with free boarding, free accommodation, free, and we even get $100 stipend monthly. Nice. So I got that admission in 2015, and that was when I got introduced to Python programming for the first time. That's so my background is in math. Throughout my days at the University of Ibadan, I never did any computer science. I always worked with computers. I always did HTML, CSS, web design. Those are things I picked up along the way, but no heavy programming. So I did the master's, and I got introduced to Python within 2 weeks. And that just, kind of opened up a channel of what I've been waiting for so long. And the fact that there were tutors at Ames and the lecturers were from all over, were always enthusiastic to answer your questions and teach, that just made it easy for me. Yes. So 2 weeks of Python programming at Ames was not enough. It was enough to whet my appetite, but not enough to teach me everything I needed. Exactly. So I went on Coursera. There was internet at Ames. I had a dedicated computer to myself in the lab. These are all of the resources I didn't have back in Nigeria. So,
and that was in Ghana?
That was in Ghana, yeah. I was at the Ghana Center then. Somewhere close to Cape Coast. So I went on Coursera, and I took, an introduction to Python programming specialization course. I applied for the financial aid, so I did all of that for free, and that was taught by Chuck Severance. I think millions of people take that course on Coursera. So that that kind of just kept teaching me more of the concept. And then another lecturer came from Pacific University in the United States, Professor Nancy, and she introduced me to graph theory for the first time again. And graph theory is just the study of how things connect. If you use Google to travel from one point to the other, you're already using an application of graph theory. So that was how I combined those two concepts, the programming in computer science, and then the graph theory and algorithms, which is a bit of math and computing. And I did a bit of master's projects that I was able to publish the software that came out of that, and that led to the next step. So how did I get to Glasgow? Somebody from Glasgow came to Ames in 2016 while I was working as a TA. So when I finished my master's, I finished with a distinction. I was even the valedictorian, and gave the speech. But then I wanted to do more, because the master's I did gave me the confidence and feeling that I could do more, and combining graph theory and programming. So I always applied for PhD programs all over the place. I even applied for masters, just to leave the space to get myself exposed to work
new
with
environment.
Yes, yeah. And so I applied for several, programs, lots of rejections. I did GRE, I did TOEFL, just so I could up my portfolio a bit. But when Professor Uli came to Ghana in 2016 from Glasgow, he came to teach modern topics in algebra, and I was working as a tutor at Ames then because I hadn't gotten anywhere to go.
So how long were you in Ghana for?
So I was in Ghana for 2 years, actually.
Wow.
I did the master's for 1 year, then I worked as a teaching assistant for 1 year.
I see. That's interesting.
Yeah. So while I was working as a teaching assistant, somebody came from Glasgow and thought I shouldn't still be here as a first class student, distinction masters. I should be somewhere else. And I haven't gotten anything. I've been trying, and so we're talking about my interest. They told him what I did with my masters, that I worked on matchings and graphs, and that just caught his attention. And he said, you know what? I have this friend in Glasgow in computing science, Professor David, who does matching algorithms, who works with the NHS, who designs the algorithm that NHS uses to find optimal sets of swap between kidney patients and those who looking for donors. And I just thought that sounds like an exciting application, and I'd like to work with. So that was how everything started. I reached out to David, I set up an interview, applied, and I got the funding to come to my PhD. So I came to Glasgow in 2016.
Was that the James McCune Smith?
That hadn't started yet. So I got the college. Yes, I got the College of Science and Engineering scholarship. 1 out of 8 scholarship for lots of people. And I couldn't believe I would get that, but I did.
That's great. That's fantastic.
So that was how I came to Glasgow in 2016 to start the PhD. And then I did the PhD for 3.5 years, finished in July 2020. And before I finished the PhD, I got an offer to stay on as a lecturer. So I started my job as a lecturer in August 2020. And the story continues till now.
Yes, and we're going to hear more about that story as we move along in the show. That's fantastic, very inspiring, and I think a lot of people who are trying to do what you've done probably have 1 or 2 things to learn from that. So now we're going to take a music break, and when we come back, we'll continue our discussion with Dr. Sofiat Olaosebikan. For our new music break, we'll be listening to Tana Musica Aria for Lagos. We'll be right back. Tana Musica. Yeah. I get time to rumba dance, with reggae, my concert tango all the way. It's the real awashe, Aria means enjoyment, better entertainment. Invite all your neighbors, Aria for Lagos, One day, to fi kawole ron faji lawa, aja shere, mama kawole
àsìkò eré ká ṣeré o, yeah. Àsìkò iṣẹ́ ká ṣiṣẹ́ o, Àríyá for Lagos, you cannot forget us. Àríyá forever o, yeah. Kí ló dé yé wá dé tó fi kọ́wọ́ lẹ́ran fàájì láwa. Àjẹṣeré a máa kọ́wọ́ lẹ́ran fàájì láwa. Ẹ dìde ẹ mú jó bàbá, ó yẹ ẹ mú jó màmá yé. Ẹ̀yin bọ́ìsì mú jó jàre. Ẹ̀yin ọmọge, àríyá ti dé ẹ dìde. Kájọ jíjó tuntun yé. Àríyá ti dé ẹ dìde. Kájọ jíjó ayọ̀, 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 yọ̀yọ̀, ayọ̀, ẹ jíjó ayọ̀, 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 yọ̀yọ̀, ayọ̀, ẹ jíjó ayọ̀.
Yes, that was Tana Musica Aria for Lagos. And I thought that was a good song to play because Dr. Olaosebikan mentioned that she was born in Lagos. I was born in Lagos as well, grew up in Lagos. So yeah, I can really relate to that song. Well, this is the Science Show on Jambo Radio Scotland with Dr. Dada, broadcasting live from Glasgow. Again, you can listen on DAB, you can watch us live and listen to us live on jamboradio.co.uk. You can also listen using the Jambo Radio app. Of course, again, episodes are uploaded to the Jambo Radio Scotland YouTube channel. So now we're going to continue our discussion and our interview with Dr. Sofiat Olaosebikan, just to know a little bit more about her research and the work that she's carrying out currently at the University of Glasgow. So, welcome back,
Thank you.
Dr. Olaosebikan. So, would you like to tell us in lay terms, if you like, in as simple as possible terms, what your PhD research was on, and then maybe develop into what you're working on now?
Yeah, in as simple as possible terms.
As
yeah,
simple
of
as
course.
possible. Yeah.
This should be easy. So, what I did for my PhD was to come up with a set of instructions. I don't want to use algorithms. A set of instructions that the computer can follow to solve problems that arise in practical applications. And the category under which this problem fall is known as matching problems. So my PhD was on matching problems. And as a very small example, toy example that we can relate with, in the United States, when doctors need to be matched to hospitals for their residency program. So they finish their medical school and they want to go to the hospital for maybe practice and residency so they can become, independent. The doctors come up with a short list of hospitals that they would like to be assigned to. And then the hospitals also come up with a list of doctors that they would like to take on. And the doctors list could be formed based on the exams that these doctors have taken, maybe the grade. And this list have to be strictly ordered. So a doctor can say, my first choice is John Hopkins, and my second choice is this, my third choice is that. And the list is going to be the same for all doctors. So it could be 5, 6, 7. And the hospital's list also has to be strictly ordered. We want Dr. A as first choice, Dr. B as second choice, and so on. And these hospitals have the notion of capacity, because a big hospital could be able to take on, say, 100 doctors, but a small hospital could say, we can only take 40 or 50 doctors. Now, the doctors, of course, cannot go to more than one hospital because, they have to be there the whole time. So this is an example of a matching problem. We have doctors on one side, hospitals on the other side, and there's preferences involved. And these hospitals also have capacities. Yeah. Now, my job is to come up with the algorithm, the set of instruction that the computer would follow to optimally allocate those doctors to those hospitals that respect their preferences, that also respects the hospital's capacity.
I see.
And that's a very, layman example of matching problem. So that has lots of applications beyond hospitals' residence allocation. And I mean, somebody could say, why do we need a computer? Why can't we do it ourselves? In the United States, as of now, there are up to 40-something thousand doctors that want to be matched to hospitals every year. And if we take their preferences and we decide to do it manually, it's going to take a lot of effort, human effort. And we also want to consider the notion of fairness. We want these doctors to go to a hospital that is that they rank highly on their list. How do you now deal with thousands of doctors going to, thousands of hospitals and the capacity? It's impossible for a human to reason, but computers can do these things faster than we could. But what people don't know in general is that computers are fast, but they are not smart. Trust me. We humans are the ones that tell the computers what to do. If you just leave a computer sitting there and you don't give it an instruction, it's going to be there all day long. So we have to communicate to the computers in a language that they understand. Yeah. And that is where programming language comes in. Programming language is the language that we humans use to communicate to the computers. And there are lots of them, just as there are lots of languages. Python is just one of those that I use. There is Java, there is MATLAB, there is C, and that's not the topic of today.
So which one is your favorite programming language?
Python, easily. Well, because that's the one that, that's the first language I learned. It's
the language of your heart.
Yeah, it is. And it's one language that is easy to relate with. And yes. when you can write Python well, you can easily code other languages. And I did that. I knew only Python, and I was teaching somebody MATLAB. I was debugging Java, and I think I did Java and MATLAB without learning them at all, just from knowing Python. So it's anyway, welcome to Python, everybody. Yeah, so that's where were we? We humans can't do the problems on our own. We need to talk to the computers in a language they understand. And we need to feed the computer the set of instructions to follow. And we need to feed them the instance of the problem, the doctors, the hospitals, the preferences, the capacity. And then we need to click run. And then they give us the solution and we interpret it. Yes. Now, that instruction that we pass to the computer, that is what everyone knows as algorithm. Everybody actually uses algorithm. If you've ever baked a cake, if you've ever walked from one place to the other, you don't even need a computer to use an algorithm. A recipe for baking a cake is an algorithm. The step you come up with in your head when you're in a shop. You want to go pick a milk and you're at one end and you're like, if I go this way, I'll get there. That's an algorithm.
So basically, a set of instructions.
That
guides the process.
That leads to the solution. It's an algorithm.
Fantastic.
So everyone uses an algorithm. Yeah. So we dub it algorithm because, we can easily... So we as computer scientists and as a mathematician, what we do is design that set of instructions using, graph theoretic approaches, or we use all of the existing theories that people have developed that has been proved to be correct. We study patterns in the graph, and I mentioned that if you've ever used Google Maps the other time, you've used graph. And basic definition of a graph. Think of Facebook. Think of the network of friends on Facebook. You, as someone, you can see yourself as a point on Facebook, and someone else as a point. And if you are friends with them, there is a line that will connect you with that person. Yes. And then if you build up that graph, that network of Facebook friendship, the structure you get is what we call graph. So nodes, points represent people, and edges represent relationship or friendship. Nice. Same as Twitter. Same as road network. Same as telecommunication, same as airline. So things are points, same as DNA, RNA, all of this gene sequencing. In chemistry as well, if you can think of a dot and edges that goes from one end to another, and that could model relationship, that could model how diseases spread, that could model how information travels, that could model how communication happens, or how everything that you can model as vertices and edges, points and lines, is the structure that is formed is called a graph. So we study that structure using, math and some methodology and techniques, and we find patterns in them, and we prove that what we found is correct, and then we combine all of those instructions together, and that forms the algorithm that solves a specific problem.
Fantastic.
Yeah. So what I did during my PhD was to design different sets of algorithms, different sets of instruction for different classes of matching problems, some of which includes student project allocation problem, which was what my PhD was focused on.
I see.
University department, lecturer has to supervise students at the end of the year. Student wants to, take on projects.
And there are preferences.
And there are preferences involved. And there are capacity. I mean, you're a lecturer. You don't want to supervise 20 students, for instance. That's too much. So that was one example of matching problem that I studied during my PhD. And another.
What about now?
Yeah.
Like, is it similar sort of lines of research, or have you kind of changed a little bit?
I mean, so the problem, like I said, has lots of applications, and let me say in general, what I'm interested in as a researcher is designing efficient algorithms and techniques that will enable us find optimal solution to optimization problems in general. And one example of the optimization problem is the matching problem.
I see.
And so my research is pretty broad, and different applications attract me. And the current, so I'm still looking at matching problems, trying to continue to advance what's known in the field. And I have also started looking at problems in wireless networks. I just started working with some researchers in the School of Engineering at the University of Glasgow, actually. And I realized that there is also a similarity between some of the problems I've looked at and the problem of actually trying to allocate users, your phone, to access points so they could get connection. Yes. Again, users, your phone, your TV, they are all the points in space. And when you turn on your phone and you need to connect to the internet, or you need to call a friend, what it does is it connects to the nearest base station to serve you. And how does the base station decide who to give service, and how do we decide how to allocate these things in a way that is optimal and fair for all of the users involved in the network? How do we maximize the network performance so you get a better bandwidth? All of those answers. How do we minimize power? So that again is one of the problems I'm currently looking at. We are looking at the next technology for 6G, which is self-free massive MIMO. So the structure of the current cellular network, 1G to 5G, actually is entirely different from the structure of the next technology that engineers are thinking of for 6G, which is self-free massive MIMO. So the self-free massive MIMO. So MIMO is multiple inputs, multiple outputs. So self-free, as the name implies, the current network has boundary, has cells. That's why when you move, when you're driving, or when you're walking sometimes, or when you're in a tunnel, your call disconnects. That's because you're changing base station. So there's a cell involved. The current technology, or the next technology, they are thinking of removing the notion of boundaries so that users can have better network performance. So when they remove that boundary, when they change the structure of the network, it changes the algorithm that needs to solve the problem as well. So what I'm looking at with my research team is how can we design efficient algorithms. You'll see I keep honing on efficient. Efficient is important because we don't just design algorithms. Some algorithms would take computers the age of the universe to find the solution, because the problem instance in practice are large. And if you just have anyhow algorithm that is not efficient, your solution is not going to be returned in a reasonable amount of time. Let's put it that way. For
example, if you want to go from A to B, you could go the long way, like a silly way.
Well, that
gets there.
That's actually one way. You could say that is suboptimal. Optimality is different from efficiency. How good a solution is different from how fast do we get that solution. Those are two things we try to work on in optimization problem. Yeah, how good a solution. Sometimes they trade off time and optimality just because the problem is hard to solve in practice. But sometimes the problem is not hard. We can find the best solution quickly, but we just have a terrible algorithm that takes so long that you will just be waiting for your Google Maps to run. That's not because your phone has hanged. That's because the algorithm is bad. Imagine when you sit and you are trying to browse for Amazon products or Google something online or search, and you Google and you press enter and it's rolling and it's rolling. You can't even sit for 5 seconds. You're just going to stand up or close the computer or find a better browser. Now, so we need algorithms that terminate in seconds so that we don't test the patience of our customers or people. So the design of efficient algorithms is pretty much what I'm concerned about. And it's easier said than done.
Yeah, indeed. So
it takes a lot of effort.
So in the interest of time, maybe we can ask a few questions and get some brief answers. So questions that maybe are on people's minds about algorithms, right? So first of all, what is all this thing about algorithms taking over the world? So how would you answer that briefly? Have algorithms taken over the world?
Yeah, I mean, maybe what we want to say is, has technology taken over the world? This is just me rephrasing. Again, if we go back to the definition of algorithm, it's just a set of instruction for real. And the people, you have to combine this with several other technological terms to get it working or to solve the problem. So I don't think it's the algorithm per se. Yeah, they are behind the scene. The algorithms are behind the scene of almost everything we are using nowadays. I had to use Google Maps to get here today.
So the answer is yes then?
Well, yeah.
So for example, there's, social media. There's, everything to do with ranking on Google or, platforms like YouTube, as you mentioned, Twitter. These platforms seem to be run by algorithms. And small businesses, a lot of small businesses basically are at the mercy of these algorithms. So what do you think about that? Do you think it's going more in that direction?
Yeah, I mean, the world keeps evolving, right? Imagine 100 years ago, what did we have? And I mean, if you take that away from people's life nowadays, the productivity, efficiency, people, I don't think the children born in this age can even survive without all of these things. And I think the more we grow, I think it's just, we'll continuously depend on technology, on algorithms. And in my opinion, people are doing so much research. I mean, I just mentioned 6G now. Some people have not even wrapped their head around 5G. And this is just how much advancement is happening. So, yes, I think technology is here to stay. And algorithm also fits in. And we'll continuously need them to solve problems and to make our life so much better and to do things efficiently. Devices keep growing. People keep buying more phones and more, data. And application area also keeps growing. Now there's the talk of smart homes. You can be somewhere in Nigeria and be communicating with your home in Glasgow. You can turn off your heating. You can wash your clothes. And again, that's technology. There's all of this, sets of instructions involved in that design process. So, and I think it's only just beginning.
Yes. So, well, that's it. You've heard it from the experts. Algorithms have taken over, and they will continue to take over even more. So, with that, we've come to another music break. We're going to listen to Tana Musica, Make You Happy. We'll be right back.
Na 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 na. Lo 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 lo. Ta na 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 na. Ta na yo 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 yo. No need to tell anybody how we dey do you for body, yo. Forget your sorrows and your worries. I just want you to move your body, yo. Tana dey here for you, just to make you happy. Everyone, I want you to know, just Africa dey here for you, just to make you happy. Eternal music, just to make you happy. Everyone I want you to know, just to make you happy. Oh yo yo.
Well, this is the Science Show with Dr. Dada on Jambo Radio Scotland, broadcasting from the city of Glasgow. So now we've come to nearing the ending section of our show, and we have one or two questions for Dr. Olaosebikan, just to know a little bit more about some other aspects of her life. So first, we'd like to know, do you have any hobbies? What do you do when you're not working? Just briefly.
Well, you could probably find me at the university gym.
Nice. So keeping fit, that's nice.
I love to work out. I love to lift heavy weights.
That's great. That's great. I know Baron Otuekong is also a gym person. So that's fine. So Baron, by the way, is one of our producers in the studio. So, again, would you like to share with us? I know you're Yoruba, and I'm Yoruba as well. So I speak Yoruba. So are there any things like sciencey things that have, meanings in Yoruba that you'd like to share with us?
Yeah, I can't even think of one on the spot.
So I know, okay, for example, let me start us off. I know how to say addition in Yoruba. I know you know that as well. For sure, you do. It's aropo.
Okay, I know it's
aropo, like addition, right?
I'm sure my Yoruba peeps are going to be disappointed.
No, I know it's not easy to come up with it, because you don't speak Yoruba a lot these days, right?
It's hard to, you're surrounded by English speakers, so.
So, okay, what about computer?
What's that gonna be? What's computer? Trust me, I can't think of anything fake.
Let me see.
Can we ask the audience?
Yeah. Well, people are free to call in, but computer. I know it has error in it. Okay. So in Yoruba, everything to do with machine is error. So, for example, the TV is error mohunmaworan. That is a machine that captures voice and or plays voice and. I mean,
when you
video.
say it, then it becomes clear. Like,
I know that word. But so
error musheya.
It will be something like that. Yeah, it will be something like that.
Because my job, computer makes my work fast. So.
Yeah, it would be. It's probably that or something that sounds similar to that.
Maybe.
For sure. So that's interesting.
But at least now they know I can speak Yoruba. So.
Exactly. And don't you find it interesting that a lot of the sciences actually don't exist in African languages? That's basically what it is. Because I couldn't say a lot of physics, explain a lot of physics in Yoruba, because I don't know how to say photon. I don't even know where I would start. Like I would say, eyo, what would I say? I know light is but how would you say? You need to come up with that, and I think that's something to think about, isn't it?
I think there are some people actually studying Yoruba language who could, come up with terminology. Trust me, there are Yorubas that I have no idea they're existing.
Me too.
Yeah,
so many.
I try to speak Yoruba proper with somebody studying Yoruba at the University of Ibadan.
Yes.
Went into his apartment to invite him to be the MC for an event. And I said, "Enle onileo." Then he answered me. And then I said, "She dadalabai." Then he answered me. Then we kept having that conversation. He kept speaking the Yoruba up to a point that I had to find the English to express myself.
You're like, okay, that's
enough. I'm done. And he kept going on in Yoruba. So I'm like, wow, this is impressive. So maybe we need to establish that, area of not research, but study.
Yes,
I think
indeed. I know someone online on Twitter. I found I can't remember her name now, unfortunately, but she's doing something like that. And she's into computer science as well. You probably know her. And she does, sometimes she makes a short video explaining about cybersecurity, I think. And it's
Yoruba.
very interesting. Yes,
Awesome.
It's very interesting. We should get her on the show maybe one of these
please
days.
do.
But yeah, it's quite interesting. So that was for our viewers and listeners, that was the surprise section. That was the bit about, trying to explain some science terms in an African language, in Yoruba. So great. So I have a couple of jokes I'd like to share. So one of them, these are about computer science and computers, so bear with me. So I think what we'd like you to do for us is to tell us whether it works or not, whether it's funny or not. Okay, so I think one of them is this. Did you hear about the computer that kept rebooting? It was Terminal. Does it work or not? Do you give it a pass or? Okay, what about this one? Whoever said that the definition of insanity is doing the same thing over and over again and expecting different results has obviously never had to reboot a computer. So that's interesting, isn't it? Because actually that statement was made by who? Albert Einstein. It was the one that said, whoever, the definition of insanity is doing the same thing over and over again and expecting different outcomes. So, this is a reply to that you've never had to reboot your computer because it can give you different outcomes, can't it? And yeah, another one, computers are useless. They can only give you answers. And this is from Pablo Picasso. That's interesting. It kind of ties in with what you said earlier. Computer is basically garbage in, garbage out. The intelligence comes from us, which leads me to this question. What about AI? Where does AI fit into algorithms? And do you see a future when algorithms for consciousness will be developed, whereby you can write an algorithm that then becomes self-aware and starts to have its own mind?
Artificial intelligence, machine learning, these are some of the areas I'm also looking into to explore for solving problems. And I've seen some research papers that are able to use machine learning algorithms to learn some of the algorithms we've designed and do the job even better. But the question, the worry I have, I'm not saying it's impossible. It's you say it's impossible until you see it happen. Is how do we actually prove that this produces the right thing? How can we trust what it's doing? Something with the algorithms discussion I mentioned earlier is that the proofs, if you remember, I said we don't just design the algorithms, we prove that it's correct. The proof actually depends on decade-olds of mathematics. Math is like a black box. When we prove with math, we trust that it's correct. If the proof goes through, that is. But if we're unable to prove that something is correct, what do we rely on then? Do we just trust it? That's hard. Scientists are finding it hard to accept that.
I think I know where your issue comes from. It's because of your maths background, because of mathematics background. So mathematics, one thing I love about it is the proof. You can pick a pen and paper, actually prove something. And combining that with technology, the world of, the evolving world of AI and so on. I clearly see how that.
So we would need a black box for AI or machine learning to say, we can trust that. And beyond that, talking about consciousness and all of that, we've seen self-driving cars and all of this new technology. Again, my worry there is when it comes to choosing between a cat and a baby, who do you kill? How do you decide? How does a cat make all of this? How does a car make all of this decision? Human beings, we are designed to, to study the situation and make quick informed decisions sometimes, even if it means you swerving your car. But what if the self-driving car has been, how has it been designed? It all boils down to who designed the algorithm behind the self-driving car. And what's their personality and what's their thought about life. And that affects how the car makes decision.
Yeah.
So it's
so those are I'd say those are open questions.
Open questions
about algorithms
which is
their
not
impact.
impossible. We need to keep advancing the field.
Yeah.
And
We'll have to call it a day there, I'm afraid. Maybe we'll get you back into the studio
God.
for another run. But yes, this brings us to a close on this week's edition of the show. And we'd like to remind you, if you'd like to learn more about the advances and developments in science and technology, and especially how these impact everyday life, well, this is the place to be. So we'd like to thank our guests. And we'd like to thank all our listeners and the production team here in the studio. And to play us out, we'll listen to Tana Musica Selenkajo. And until next week, we'll say, stay curious.